This is SpaceTime, Series 28, Episode 54, for broadcast on the 5th of May, 2025. Coming up on SpaceTime, discovery of a vast molecular gas and dust cloud right next door to our solar system, Jupiter's giant polar cyclones under the microscope, and the sky is falling, an out-of-control Russian spacecraft about to crash back to Earth. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a vast invisible molecular gas and dust cloud right near our solar system. This massive, potentially star-forming body, reported in the journal Nature Astronomy, is one of the largest single structures in the sky and among the closest ever to be detected near the Sun and Earth. The vast ball of hydrogen, long invisible to scientists, was revealed by looking for its main constituent, molecular hydrogen. This discovery marks the first time that a molecular cloud has been detected using light emitted in the far ultraviolet realm of the electromagnetic spectrum, and it opens the way for further explorations using this same approach. Astronomers have named this molecular hydrogen cloud Eos, after the Greek goddess of mythology who was the personification of dawn. The study's lead author, Blakesley Burkhardt from Rutgers University, says the discovery opens up new possibilities for studying the molecular universe. Molecular clouds are composed of gas and dust, with the most common molecule being hydrogen, the fundamental building block of stars and planets, and essential for life as we know it. But they also contain other molecules such as carbon monoxide. Molecular clouds are often detected using conventional methods such as radio and infrared astronomy. These can easily pick up the chemical signatures for carbon monoxide. But for this work, scientists employed a different approach. Burkhardt says it's the first ever molecular cloud discovered by looking for far ultraviolet emissions of molecular hydrogen directly. And the data showed glowing hydrogen molecules detected by fluorescence in the far ultraviolet. The cloud is literally glowing in the dark. Eos poses no danger to Earth and the solar system, but its proximity does present some unique opportunities for astronomers to study the properties of a structure within the interstellar medium. The interstellar medium, made up of gas and dust that fills the space between the stars within the galaxy, serves as the raw material for new star formation. Burkhardt points out that when astronomers look through their telescopes, they can catch whole star systems in the act of forming. But they really don't know in much detail what's going on. And that's why this new discovery of Eos is so exciting. It allows astronomers to directly measure how molecular clouds are forming and disassociating, and how a galaxy begins to transform interstellar dust and gas into stars and planets. Eos, the crescent-shaped gas cloud, is located about 300 light-years away from Earth. It sits on the edge of what's known as the local bubble, a huge gas-filled cavity in space that encompasses our entire solar system. Astronomers estimate that Eos is vast in projection across the sky, and it has at least 3,400 times the mass of the Sun. But it's not going to last long, at least not in cosmic time. Computer simulations say it'll probably evaporate within the next 6 million years. But it's a fascinating discovery because it shows that the use of the far ultraviolet fluorescence emission technique could rewrite science's understanding of the interstellar medium, uncovering hidden clouds across the galaxy and even out to the furthest detectable limits of the cosmic dawn. Eos was revealed in data collected by a far ultraviolet fluorescence imaging spectrograph on the Korean STSAT-1 satellite. Now, a far ultraviolet spectrograph breaks down the far ultraviolet light being emitted by a material into its component wavelengths, just as a regular prism does with visible light, creating a spectrum which astronomers can then analyse. Eos is dominated by molecular hydrogen gas, but is mostly carbon monoxide dark, meaning it doesn't contain much of that material and doesn't emit the characteristic signatures detected by conventional approaches. And that explains why Eos has eluded discovery for so long. This is SpaceTime. Still to come, Jupiter's giant polar cyclones under the microscope and an out-of-control Russian spacecraft crashing back to Earth this week. All that and more still to come on SpaceTime. Hey there, SpaceTime listeners, buckle up because I'm about to thrill you and tell you about our new sponsor, Insta360, the wizards behind cutting-edge 360-degree action cameras. Their brand new Insta360 X5, which dropped on April the 22nd, is an absolute game-changer for capturing your adventures, whether you're exploring the cosmos or just your backyard. Now picture this, the X5 shoots jaw-dropping 8K 30 360-degree video, grabbing every angle in one go. No need to fuss with aiming, just hit record, soak in the moment, and later with your Insta360 Stick mobile app, pick up any perspective you want. This app's loaded with AI-powered tools that make editing a breeze. You can craft epic shots without breaking a sweat. From immersive first-person views to creative third-person angles, this camera does it all. And what's powering this beast? Well, it's a triple AI chip with buttery smooth performance. It's paired with massive sensors and a dedicated low-light mode that delivers stunning clarity day or night. Plus, the X5 lenses are the toughest Insta360s ever made, and they're fully replaceable. So go ahead, take that daring shot with total confidence. To bag a free 114cm invisible selfie stick worth $24.99 US with your Insta360 X5 standard package purchase, head to storeinsta360.com and use the promo code SpaceTime. But it's only available for the first 30 standard package purchases. And for more information, be sure to check out the links in our show notes. Insta360, brilliant technology for a brilliant camera. And now, it's back to our show. New data from NASA's Juno mission is shedding fresh light on the fierce winds and cyclones which are raging in the far north of the gas giant Jupiter. And it's also been examining the extreme volcanic actions witnessed on its fiery moon Io. The new findings, presented at the European Geosciences Union General Assembly in Vienna, are based on fresh observations peering below the Jovian atmosphere's cloud tops and updated scans of Io's crust. Not only has the new data helped develop a model to better understand the fast-moving jet streams which encircle Jupiter's cloud-festooned North Pole, it's also revealed for the first time the subsurface temperature profile of Io, providing fresh insights into the moon's inner structure and volcanic activity. The study's lead author, Scott Bolton from the Southwest Research Institute in San Antonio, Texas, says everything about Jupiter's extreme. The planet's home to gigantic polar cyclones bigger than continental Australia, fierce jet streams faster than anything seen on Earth, and the most volcanic world in our solar system, Io. And it also has powerful auroral activity and the harshest of all radiation belts. While Juno's microwave radiometer was designed to peer beneath Jupiter's cloud tops, mission managers have also trained the instrument on Io, combining its data with that of Juno's Jovian infrared auroral mapper to provide a far deeper insight. And when they combined the microwave and infrared data on Io, they saw evidence of still warm magma that hadn't yet solidified below the moon's crust, and not just in one spot. In fact, the data suggest about 10% of Io's crust has these remnants of slowly cooling lava just below the surface. The results may help provide fresh insights into how the moon renews its surface so quickly, as well as how heat moves from its deep interior up to the surface. The infrared data alone shows that the most energetic eruption in Io's known history, which was identified during Juno's December 27 Io flyby last year, was still spewing lava and ash as recently as March the 2nd. And Juno's mission scientists believe it's probably still active today. In fact, that should be confirmed later this week when the spacecraft's current Io flyby takes place. That's when Juno will swoop to within 89,000 kilometres of the moon's volcanic surface. On its 53rd orbit back in February 2023, Juno began radio occultation experiments to explore the gas giant's atmospheric temperature structure. Now, this involves the transmission of a radio signal from Earth to Juno and back again, passing through Jupiter's atmosphere on both legs of the journey. As the planet's atmospheric layers bend those radio waves, astronomers can precisely measure the effects of this refraction, and they can derive detailed information about the temperature and density of the atmosphere. The process works so well and provides so much data that Juno's now completed 26 radio occultation soundings. Among the most compelling discoveries so far was the first ever temperature measurement of Jupiter's North Pole stratospheric cap, which revealed that the region's some 11 degrees Celsius cooler than the surrounding area, and it's encircled by winds exceeding 160 kilometers per hour. The new findings also focused on the cyclones that haunt Jupiter's northern latitudes. Years of data from both the Juno Cam visible light imager and the infrared auroral mapper have allowed Juno scientists to observe long-term movements in Jupiter's massive northern polar cyclone and the 8 daughter cyclones that encircle it. Unlike tropical cyclones, hurricanes and typhoons here on Earth, which typically occur in isolation and at lower latitudes, Jupiter's are confined to the polar regions. By tracking the cyclone's movements across multiple orbits, scientists were able to observe that each storm gradually drifts towards the pole. That's due to a process called beta drift, the interaction between the Coriolis effect and the cyclone's circular wind patterns. It's similar to how hurricanes, typhoons and tropical cyclones on Earth migrate. Earth cyclones break up before reaching the poles due to the lack of warm, moist air needed to fuel them, as well as the weakening of the Coriolis effect near the poles. What's more, Jupiter cyclones tend to cluster while approaching the pole, and their motion slows as they begin interacting with neighbouring cyclones. The study's co-author, Juno investigator Yochai Caspi from the Weizmann Institute of Science in Israel, says these competing forces result in the cyclones bouncing off one another in a manner reminiscent of springs in a mechanical system. The interaction not only stabilizes the entire configuration, but also causes the cyclones to oscillate around their central positions as they slowly drift westward clockwise around the Jovian poles. This new atmospheric model helps explain the motion of cyclones not only on Jupiter, but potentially also on other planets, including the Earth. One of the great things about Juno is its extremely elongated orbit, which is designed to avoid as much of Jupiter's intense radiation belts as possible. Now, this ever-changing orbit means scientists get a new vantage point during each flyby, thereby increasing the cascade of discoveries being made about the solar system's largest planet and its multitude of moons. This backgrounder from Mission Principal Investigator Scott Bolton from the Southwest Research Institute in San Antonio, Texas.
The main goals of Juno are to study the origin of Jupiter, and it represents giant planets, as we know, around our star, as around other stars, and it holds a lot of key secrets on how we formed the solar system, where Jupiter came from, and also the rest of the solar system. There's a couple of unique things about Juno. We're solar powered. We're the first ones to go out that far to Jupiter's distance, solar powered. Jupiter's 5 times the distance from the sun as the Earth, so the amount of sunlight is 25 times less, so we're very efficient, and we're pushing the envelope on solar power there. When we get to Jupiter, we go into a polar orbit. It's the first time a spacecraft's gone into polar orbit at Jupiter. We go into a very close polar orbit. So not only are we over the poles, but we're getting closer to Jupiter in our orbit than any other spacecraft has gone orbiting Jupiter. We're only 5,000 kilometers above the cloud tops. And so we're skimming right over those cloud tops, and we're actually dipping down beneath the radiation belts, which is a very important thing for us because those radiation belts at Jupiter are the most hazardous region in the entire solar system other than going right to the sun itself. And we have a vault in the middle that holds our electronics to protect them from these high-energy particles. We're basically an armored tank going to Jupiter. Jupiter probably formed first. It's the largest of all the planets. In fact, it's got more material in it than all the rest of the solar system combined. If I took everything in the solar system, it could all fit inside Jupiter. And in fact, Jupiter is probably more than twice as massive as the rest of the solar system put together. So after the sun formed, it got the majority of the leftovers. And that's why it's very interesting to us if we want to go back in time and understand where we came from and how the planets were made. Jupiter holds this secret because it's got most of the leftovers after the sun formed, and so we want to know that ingredient list. What we're really after is discovering the recipe for making planets, and we're back at the first step of making sure we have all the ingredients in that recipe. So there's 2 key experiments that we have to help us understand the origin of Jupiter. One is we go after the water abundance. We want to know how much water is inside Jupiter, which represents how much oxygen. Oxygen is the 3rd most abundant element in the universe and in the sun, so it's a big missing piece if we don't understand it. The other is whether Jupiter has a core of heavy elements at the center whether it's just gas all the way down. There are zones and belts, different colors. There's a giant red spot. We've been observing this giant storm for over 300 years. One of the fundamental questions is how deep are the roots to that red spot? How does it maintain itself for so long? How deep are the roots to the zones and belts? Are they just a surface feature, like a meteorological layer that's very, very thin? Or does it go down deeper, and maybe is it demonstrating to us how Jupiter is structured inside? So our microwave experiment tells us a lot about this deep underneath the clouds dynamics and the composition. Two of the other questions, which is what's inside of Jupiter, magnetic and gravity fields. And the way we measure the gravity field is through something called a Doppler shift. So what's happening is that spacecraft flies by Jupiter very, very close, and we watch how the Jupiter's pushes and pulls on its velocity. So we model it as if all of the mass in Jupiter is in one point, and then we look at how the spacecraft has behaved differently in its trajectory from that assumption, and then we're able to back that out and be able to say how the mass is distributed inside the planet. In fact, you can even say how the planet is rotating inside, whether it's a solid body or a series of concentric cylinders. Also, partway down through Jupiter, the hydrogen actually becomes metallic. It's under such great pressure. This is a very strange substance, very different than what we have here on the Earth. The hydrogen starts behaving like a fluid, a little bit like mercury in your old thermometers, and it conducts. And somewhere in that layer is the magnetic field is created. That's probably the source region. So we're very interested in understanding the magnetic field. Jupiter's magnetic field is tilted about 10 degrees with respect to its rotation axis. So on the end of one of Juno's solar arrays are magnetometers. It's in fact got a magnetometer boom, and that's one solar array looks a little bit different than the other, and that's the reason. Another of our objectives is to study the polar magnetosphere. Because we're going over the poles, we're perfectly suited to study the great aurora, the strongest aurora in the entire solar system. In fact, Jupiter has the strongest magnetic field and the brightest aurora. We have a number of instruments that go right over those magnetic field lines and see the particles coming down and causing that aurora. And then when we learn about Jupiter's polar magnetosphere and aurora, we'll be able to compare it to Earth's.
That's Scott Bolton, the mission's chief investigator from the Southwest Research Institute in San Antonio, Texas. This is SpaceTime. Still to come, an out-of-control Russian spacecraft about to crash back to Earth in the next few days. And later in the Science Report, a new study warns that 83.7% of the world's coral reef area is now being impacted by heat stress. All that and more still to come on SpaceTime. A failed Soviet-era spacecraft designed to land on the planet Venus is about to crash back on Earth. The Venera 8, or cosmos.First spacecraft, is expected to re-enter Earth's atmosphere on an uncontrolled tumbling flight path on May the 10th. Launched way back in March 1972, the Cosmos 482 failed to escape low Earth orbit. That was due to flight systems programming errors, which caused premature stage separation. That prevented the probe from escaping Earth orbit, leaving it doomed to spend the last 53 years circling the planet. Now, shortly after being placed in its parking orbit, the spacecraft split into 4 sections, 2 of which re-entered Earth's atmosphere within a month. These included a group of 4 13.6 kilogram, 38 centimetre wide spherical titanium alloy fuel tanks. They eventually crashed back to the ground within 16 kilometres of each other near Ashburton in southern New Zealand. And 6 years later, in 1978, another piece of space debris, suspected of being another spherical fuel tank from the Cosmos 482, was discovered half buried in the ground just outside the southern New Zealand town of Effelton. Now, the 2 remaining sections, the descent and landing module and the propulsion unit, were circling the planet in a 210 by 9,800 kilometre orbit at an inclination of 51.7 degrees. And slowly over the last half-century, that orbit has been degrading. It's now reached a point where it's skipping on the upper atmosphere and will soon slow down enough to begin re-entry. And that's where things get dangerous. See, the 495-kilogram spacecraft was heavily engineered, designed to withstand the high temperatures and extreme pressures of landing on the hostile world of Venus. It's therefore expected to easily survive its re-entry into Earth's atmosphere and should remain mostly intact. Now, because of the uncontrolled nature of its flight path and the constantly changing atmospheric conditions, scientists can't be sure exactly where or when it will re-enter. The best they can tell us is that it could crash down anywhere: Europe, Asia, the Americas, Africa, or Australia. Although, given the vast amounts of ocean covering the Earth, a watery demise is the most likely. The bottom line is we'll only know for sure exactly where and when it hits when we get those first reports of a bright, slow-moving fireball streaking across the skies. This is SpaceTime. And time now for a brief look at some of the other stories making news in science this week with a science report. The worsening crisis being faced by the world's coral reefs has been put into focus with the release of a new study showing that over 80% of them have now been hit by bleaching levels of heat since 2023. The findings by the United States National Oceanographic and Atmospheric Administration, NOAA, says the most recent Coral Reef Watch report shows that some 83.7% of the world's coral reef area has now been impacted by heat stress capable of causing coral bleaching in the last 2 years. The report also says mass coral bleaching has already been documented in at least 83 countries and territories since January 1st, 2023. NOAA says the ongoing bleaching event is the biggest ever recorded. A new study claims people who use cannabis have a far higher risk of having a heart attack even among younger, otherwise healthy adults. The findings, presented at the American College of Cardiology's annual scientific session, covered over 4.6 million people aged under 50. It showed that over a 3-year period, cannabis users had more than a 6-fold increased risk of heart attack, a 4-fold increased risk of ischemic stroke, a 2-fold increased risk of heart failure, and a 3-fold increased risk of cardiovascular death, heart attack, or stroke. The findings are based on data pulled together by researchers from 12 previous studies, finding that for these studies, active cannabis users were at least 1.5 times as likely to suffer a heart attack. New research has raised fresh questions about the evolutionary history of some of our most unique mammals. Up until now, the expected understanding about echidnas and platypus, arguably the most unique animals on the planet, was that they were both descended from a land-based ancestor. And while the platypus eventually became semi-aquatic, echidnas stayed on the land, or so the story went. But a new study by the University of New South Wales, reported in the journal PNAS, has analysed a small bone found 30 years ago, and it shows that the ancestors of echidnas and platypi, if that's the term, actually evolved from a water-dwelling ancestor. For decades now, frightening ghost lanterns in South Carolina have struck fear into the hearts of many local residents. But now a new study reported in the journal Seismological Research Letters claims the strange orbs which appear along railroad tracks in the area and have been known to slam doors and cause other paranormal activity probably actually being caused by earthquakes. Tim Mindham from Australian Skeptics says the findings will, dare I say, shake up believers who thought they were being caused by, well, at least according to the legend, the ghost of a railroad widow.
This is a thing that's been around for a while, and people at certain times of probably the night, actually see these lights that appear in the sky and then they disappear. And it happens a fair amount of times, and people say, it's the spirits, it's the ghost. So someone said it's the wife of a train conductor who never came back as an accident, so she, after her death, is now wandering up and down the railway tracks trying to find her husband. And that's actually quite telling because it's about the railway tracks as much as anything. There's a researcher who looked at these particular ones in South Carolina who says that this area where these things is prone to minor earthquakes, but earthquakes, most of them you probably can't feel. And they said train lines tend to follow an area which is easy to build. But they're saying that earthquakes, and this is true, when they happen an earthquake, you're grinding rocks together. Quartz does it especially, other rocks as well. You're grinding them together in the same way as you'd like to bash rocks together to start your campfire. One rock against another, you get sparks. Crashing rocks together to get sparks is real. And so the researcher is suggesting that this is the case. This might be the reason why they see light. Wouldn't be a reason for seeing lights that are up there for a while, but they also suggest perhaps gas escaping gets lit by these rocks crashing together. Who knows? So suggesting that there are alternative explanations that fit in well with the evidence, because no one's there, hardly ever there to actually catch the photograph. It's too fleeting. Certainly if it's sparks coming from rocks, it's extremely fleeting. This is a suggestion. Especially in the night sky, they can't feel anything. They can't feel an earthquake that there might have been.
Yeah, ball lightning, that sort of thing. They have no idea what it is. But,
no idea what it is.
There is
a
scientific explanation for it. They just got to work it out.
Yeah, I mean, there are thousands of earthquakes every day. Most of them you never feel, the minor ones, but all over the place. Predictors and psychics will say there will be an earthquake in California. Yep, quite a lot every day. It's probably a better explanation than a widow walking up and down the railway line with a lantern. How can you carry a lantern? She's a ghost. Never mind. It's a ghost lantern. But you can see the ghost lantern. Never mind. A few slight problems with that story.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through your favourite podcast download provider and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.